Hey guys, welcome back everybody. Hope you all are doing great. Guys, this is part 8 for the complete configuration of this network topology, and I am expecting you are watching all videos in sequence. And if you are watching all videos in sequence, that means you have already knowledge about the previous configurations. Like you can see, this network is live, means my all end devices are able to access internet as well as they are able to access network resources. So here you can see I have access of PC1 and server 1. We have some servers in the network, in the internal network, and both are keep pinging to 8.8.8, and both machines are getting reply from the 8.8.8. 8.8.8 is server on internet, right? So see, we have some resources here in the internal network like server 1 and server 2. Let's say on these two server, guys, I am hosting some application. Let's say here HTTPS, right? And the domain name is pmnet.com. So as these machines are able to access internet as well as able to access these servers, all end devices are able to, all client machines are able to access the server, as well as outside users are also able to access these resources, server 1 and server 2, with the help of public IP address. So let's suppose on the internet we have some users here. So these outside user can access my server 1 and server 2, with the help of public IP address. So you can see we have two public IP addresses for server 1, 1.1.1.2 and 2.2.2.2. These two are public IP address for server 1, and these two public IP address 1.1.1.3 and 2.2.2.3. These two are public IP address for server 2. Why we have two public IP addresses for server? Because we have connectivity from two ISP. ISP1 is the primary ISP, ISP2 is the secondary ISP. Now if you are thinking how outside user will get to know what public IP address should I use to access the internal server, right? With the help of public IP address, these outside user can access the server. So guys, you are going to set up DNS, domain name system, to resolve domain name into IP address. So your domain name is pmnet.com, let's suppose, right? So your DNS server, when this user, outside user, want to access this server, simply they will open their browser, and in the browser you will type domain name www.pmnet.com, right? So your machine is going to send DNS query message to the DNS server to resolve IP address of this domain, and DNS server is responsible to provide public IP address. So you are going to configure DNS server in such a way so that it will check which ISP is up, like primary ISP is up or not. First, DNS will give preference to ISP1. See, we can configure DNS in such a way so that it can perform load balancing, right? Round robin load balancing means it will give this IP address to one user, then second user to this IP address, right? When DNS server will receive request for pmnet.com, DNS query for pmnet.com, first of all it will send this first public IP address, which is 1.1.1.2. Then when it will get second request, it will send this IP address 2.2.2.2. This is what load balancing. But in this scenario, I am not configuring load balancing because this is my active and secondary scenario. Active and standby scenario, you can see primary, secondary scenario. So you are going to configure DNS to give priority, right? I am going to give priority to this IP address 1.1.1.2. So until and unless ISP1 is up, DNS server is going to provide this IP address, right, for the pmnet.com. If ISP1 is not available, if ISP1 is down, then DNS server is going to provide this IP address 2.2.2.2, right? So actually we have two public IP address, 1.1.1.2 and 2.2.2.2. These are two public IP addresses for server 1, and this IP address, first public IP address, which is 1.1.1.2, is for ISP1, right? Means how outside users will access my internal server via ISP1, right? So outside user can access the internal server via ISP1 with the help of this public IP address 1.1.1.2, and outside user can access internet via ISP2 with the help of this public IP address 2.2.2.2. In the same way, for server 2, we have two public IP address 1.1.1.3 via ISP1 for ISP1 and 2.2.2.3 for ISP2. right? So don't worry, here on the internet you are going to set up DNS, you are going to configure the DNS, right, to resolve the IP address into domain name. Okay, and everything is working fine, guys. Even ESA firewall is doing failover, right? So failover is also working fine here. In last video we had verified that. Even if you want to verify now, I can verify it. But today we are going to take backup of all devices, right? Backup of configuration, right? Like on this all access layer switches we have some configuration like VLAN configuration, port security configuration, DTP configuration, VTP configuration, right? Then STP configuration, RSTP, port fast, right, priority, whatever configurations we have on these all access layer switches, we need backup, right? So that let's suppose if any device will corrupt or if any device will get damaged, so in that scenario we need to replace the device, right? So you should have configuration, otherwise you have to configure everything again, right? But in real time you will have lots of configuration on these devices, so for the replacement you should have backup, right? So let's suppose now I have backup of these all access layer switches, and the switch 1 is now not working fine, this hardware has failed. So engineers are replacing this device. First of all, you will arrange one FE, field engineer, who will visit to the site. Then he will, uninstall this device. They are going to insert the new switch here, and maybe you will send the configuration to mail, and after that you will take access of this switch, then you will push the configuration. But if you will not have the configuration, then maybe you need to configure everything again, right? So backup is very important, right? Like monitoring is also important. In the same way backup is also important, so that whenever I lost the configuration, I can again reload the configuration from a centralized server. In the same way I have lots of configuration on distribution layer switches, like here we have DSCP, you can see HSRP, right? This switch is the active switch for some VLAN, for VLAN 10 and 20. This switch is the active switch for VLAN 30 and 40. So I am performing load balancing at distribution layer switch. Then for the internal routing, we are running OSPF routing protocol, right? So we need backup of this configuration. In the same way, on core router, we are running many protocol. On ASA firewall, we have many configuration like failover configuration, NAT, default route, IP configuration, SLA is running there. So today you are going to understand how to take backup of routers and switches configuration on centralized server, on TFTP server. So see, I am going to take backup of these all routers on my local computer. So that's why guys, on my local computer I have installed one software. You can see here software is TFTP server, right? This is SolarWind TFTP server. So I am going to backup of all the routers configuration on this TFTP server, right? So first of all, I need to connect my network to this server, this TFTP server. This TFTP server should be reachable from everywhere, right? Server should be reachable from everywhere, then only we can copy the configuration. So I need to connect this network to my local PC first. Okay, so hope a topic is clear for today. Today we are going to take backup of configuration, right, on the TFTP server. Before that, if you want to verify the configuration, see, end machines like PC1 is able to ping 8.8.8. Ping is working here. Let me say no now, right? Now on the server also, you can see on server 1 is also able to ping internet, right? And ASA firewall is forwarding traffic to ISP1 because ISP1 is up now. So let me access ASA firewall just to verify the previous configuration. It will be easy for me. Every day we are verifying the configuration just to make you familiar. So here what we can say, so route and include 0.0, show me the default route. So see guys, default route is present on outside ISP1 interface. Outside ISP1 is G0/0, which interface is connected with ISP1, right? But if you will check the running configuration, so run route, so you can see in the running configuration we have two default route, right? And here I am using track. So track, so as my track is up, that's why router have installed this track route default route in their routing table, right? And with the help of track I am tracking ISP1, right, with the help of SLA. How you can check? So IP SLA, so SLA monitor, so SLA monitor and operational state. So you can see timeout occur is false, that means ISP1 is reachable from ASA firewall, right? And now let me access ISP router ISP1, and from here if I want to ping server 1, let's say, so what is the public IP address of server 1? Public IP address of server 1 is 1.1.1.2. see, I am able to ping the server 1, right? But I cannot access server 1 with the help of second public IP address from ISP1, right? Second public IP address is 2.2.2.2. see, it will not work because this public IP address is reachable via ISP2. But guys, in my scenario, see, both ISPs are not connected together, but in the real time both ISPs are directly connected with each other. All ISPs are connected internally. Done. So outside users are able to access the internal server. Now again let me show you some configuration on ASA firewall, like NAT configuration. So run NAT. So you can see we have some manual NAT for one-to-one translation for the server, so that outside users can access the internal server. Then we have some general rule, right, so that my all end devices can access internet. Okay, so I have installed these routes in section 2 and these all specific rule in section 1, right? So NAT, you can see manual NAT policies as in section 1. These are the manual NAT for servers. Then we have some auto NAT policies for the end devices, for the general users, like my all employees should be able to access internet. So everything is working fine, but what will happen if ISP1 bill goes down? Let me do one thing on ASA firewall. Let me check failover is working fine or not. Interface D0/0 and says shutdown. So once this interface will goes down, what will happen? SLA will goes down. First your track will goes down. So track. Your track is not down, you can see here. So now if you will check show route and say include 0.0.0. So you can see now default route is present on ISP2. Now question is, can end devices access internet now? Let me try. Yes, see, you can see ping is still working, right? So right now end devices are accessing internet via ISP2. Even the server on server 1 also you can verify. See, yes, ping is working, right? Let me stop the ping, and now let me access ISP2 router, and from ISP2 I am going to check that I am able to access server 1 and server 2 or not with the help of public IP address. So from ISP2 you can access server from second public IP address. So what is the second public IP address for server 1? 2.2.2.2, and yes, you can see I am able to access. Then ping 2.2.2.3, second public IP address of server 2. So you can see outside users are able to access both servers, server 1 and server 2. This is guys completely real time scenario, and in the same way we are configuring network in real time as well, right? So I have configured this firewall according to my experience only, right? Because in real time in the production network many time I configured this type of scenario, right? And here on ASA firewall, you can check the policies, like we have some objects So if you want to understand the configuration, just do one thing. So run object, see the object configuration, just take a screenshot of this and then you can understand it. Then so run NAT. So see, these are NAT policies. And so route, so run route, so run route. Done. This is the default route configuration. Then so run track. So this is track configuration. So run SLA monitor. So this is SLA configuration. See, I am tracking ISP1. That's it. So these are configuration on ASA firewall and everything is working fine. Now let's work to backup the configuration of each device. So guys, to backup this the backup of configuration, what I need, a application, right? So application is installed on my local laptop, as you can see. And can I access this TFTP server from here? First of all, you can verify that on your local computer TFTP client service is enabled or not. So for that, simply you can run command here TFTP. But you can see TFTP client is disabled here. TFTP is not recognized as an internal or external command. So to enable TFTP client service here on the Windows operating system, right? This is Windows 11. So simply you can open the control panel, and in the control panel go to program and features, and once you will turn on and turn off Windows features, you will get option to enable TFTP client. Yes, here you can see TFTP client and this is disable. So let me enable it, click OK. But I am not going to use my machine, my local PC as the TFTP client, but then also I have shown you that how to enable it. Now if you will open CMD and if you will type command TFTP, it will show you the detail. Like you can see, not this machine is TFTP client. Now guys, I am going to run the application. Which application? And as I told you that I am not going to use this local machine as a TFTP client, so I can disable it. Simply say OK. And now just wait for some time. Then I am going to run this application, TFTP application, on my local machine. Now I need to connect my network to this application. This application should be reachable from all devices, right? Then only we can copy the configuration. So what I am going to do, let me do one thing. I am going to add one switch here. I'm going to add one switch here to connect my network to the application, to TFTP server. So I need to add one here switch, that is your network interface, right? This is the virtual switch, or you can say this is your TFTP server. So let me change the symbol. Okay, this device is on. Now let me connect these two switch. So first of all I have to turn off my switch, and now I am going to connect it with the help of this switch. Actually what I did here, just understand guys, this is my local laptop. On my local laptop I have installed one application, that is TFTP, right? So let's suppose IP address of TFTP server is 10.1.1.1 or 5.1.1.1. because I am already using 10.1.1.1. 5.1.1.1 is the IP address of my application. Now in the same, on the same laptop, I am running EVNG as well. Or EVNG is another operating system. So if you are thinking how you are how you are running two application on same local machine, so let me do one thing. Let me open the Paint and let me clear it. Actually, this is the concept of virtualization. By the way, we will discuss it in detail in any virtualization video. If you want a separate video on virtualization, like detailed video on virtualization, just let me know in the comment section. Type yes, I need video on virtualization. I will make one detailed video on virtualization, like how virtualization technology works. So this is my local laptop. On this local laptop, actually I have installed VMware software. VMware software. This is VMware is a virtualization software which is used to install multiple operating system on a single hardware, right? So on the VMware we can install multiple operating system, right? This is my main laptop, and on the VMware I have installed EVNG. EVNG is running on VM. So guys, actually VM is virtual, right? Virtual machine. So on your local machine also you will install VMware, right? Or whatever operating system you are going to install on VMware, it will create virtual interface on your local interface, right? So it is going to create virtual interface here, right? This is the virtual interface for EVNG, and let's say this virtual interface IP address is 5.1.1.1, right? And on your local computer you have installed one application. I have installed one application, that is TFTP server. TFTP server, and this TFTP server have what IP? Let's say 5 dot or 6.1.1.1. It can be have same IP or different IP as well, right? So let me do one thing. Let me configure same IP over here. Now you can see. Now TFTP application have this IP address, which is the IP address of your laptop, physical interface of your. So the physical IP address of my laptop is 5.1.1. Sorry, not 1, it can be 2, 5 dot or 6.1.1.1. Now you need to connect EVNG and TFTP server. So actually, as TFTP is present on your local computer and EVNG is also present on your local computer, so both can belongs to, you can configure the same IP address as well on TFTP and on this virtual interface, and different IP address as well. But now we need to connect them together. So guys, to connect them together I need a switch here, right? And that is virtual switch, and this bridge is that virtual switch here, you can see, right? I'm using this one, this switch. This is the virtual switch. One interface of this switch is connected with my network and one interface is connected with my local computer, right? One interface of this virtual switch is connected with my local computer. So like this we can connect my network to EVNG network to my local computer. Like if you want to see here the interfaces, virtual interfaces on my computer, say window R. See, many NICs are there, many interfaces are there, right? Some are guys physical and some are virtual. Like you can see this is for Wi-Fi, right? On my laptop I have one NIC for Wi-Fi through which my laptop is connected with internet wirelessly. Then we have some virtual interface. You can see VMware network adapter, VMnet 1 and VMnet 8, and these both virtual interface will have IP address, right? So these are virtual interfaces on my local computer. I can have 2, 5, 8. Then we have Ethernet port here, right? This is the physical port to connect my computer to network physically. Let's say this PC, I want to connect this PC to a switch. So what I can do, I can connect my PC to switch through this Ethernet 3 port, right, with the help of Ethernet cable. This switch is connected with router, and router is connected with, let's say, again, internet. So now I have two connectivity from internet on my PC. One physical, one Wi-Fi. Correct? And as both virtual interface and physical interfaces belongs to same PC, both can communicate with each other, right? Both can communicate with each other. So same thing is happening over here in my scenario. I have installed TFTP on the local laptop, and I have run the TFTP server. Not yet, just wait. TFTP, and let me run as administrator here. Yes, now you can see TFTP is running on my local computer, right? If you want to see the IP, see the IP address of my server, 192.168.241.1. And guys, you can even check the IP address on the Ethernet port or on the virtual port. IPv4 address 192.168.50.1 is running on this Ethernet port. On the is this Wi-Fi port. It is getting IP from the DHCP, so simply I can open CMD, and in CMD I can run command IP config. It will show you the IP configuration on all interfaces. So see, this is Ethernet adapter not connected, Ethernet 3, where IP address is 192.168.50.1. I have shown you just before. Then the another virtual interface is VMnet 1, where IP address is 192.168.161.1. Then VMnet 8, where IP address is 192.168.241.1. So TFTP server is connected with this interface, correct? TFTP is connected with this interface also, 192.168.50.1, which is the IP address of Ethernet port 3, right? Even it is connected with both virtual interface and both physical interface. We have two physical interface, one for Wi-Fi, one for Ethernet cable, and two virtual interface for VMware, right? So this is the TFTP server. And now let me do one thing. Let me here check. Let me open the switch now, and on this port I will try to get IP address from the DHCP server. See, now my switch is connected with internet. This switch is connected with real internet, guys, because my laptop is connected with real network, real internet, and now switch is connected with my laptop with the help of this virtual switch. So now I can get IP address on this interface from internet, right? From the internet router, because DHCP is enabled on the internet router on my edge router. And IP address on the Wi-Fi NIC is IP config. On the Wi-Fi NIC, you can see IP is 192.168.1.8. Gateway IP address is 192.168.1.1, right? And on the VMnet 8, right, I'm going to connect this interface to my local computer, right? So through this virtual interface, I'm going to connect my network to the TFTP server. So now let me access switch 4 here, and on switch 4, enable password is here. You can see Cisco @123. So say Cisco @123. Now I have access of switch 4. So interface status. So which interface is connected with this virtual switch? 1/2. So 1/2. 1/2. You can see this port is now connected port. Now I want to configure IP here. So let me verify, let me check that this switch is able to get IP from the DHCP or not. Interface E1/2 say no SUT and no switch port, because by default switch port is layer 2 port, right? And now I'm going to say IP address DHCP. Just wait for some time. So IP interface brief exclude unassigned. So see, we have one IP address on VLAN 100, and VLAN 100 is the management VLAN. This is just to access this switch remotely with the help of SSH, right? Soon it will get one IP address from DHCP. If it is not getting IP address from the DHCP, what we yes, from the DHCP, what you can do, you can configure one IP address from the same range, and then you can ping to the TFTP server to your local machine. If you are able to ping the local machine, that means you can save the configuration on TFTP server, because TFTP server is listening all IP addresses. TFTP server is listening all IP addresses, you can see here, right? So why I'm not getting IP from the DHCP here? Switch 4. So IP interface brief E1/2 is unassigned, port is up, line protocol is also up. I'm expecting one IP here on this port. Let me connect it with management port. Sorry, yes, management port. And now go to switch 4, debug IP DHCP server packets config T interface E1/2 say shutdown, and then again no shutdown. No IP address DHCP, and again say IP address DHCP. So IP interface brief. Okay, IP address of switch 1 is 192.168.100.13. Let me do one thing from my local PC. Let me try to ping this IP address. I cannot ping this IP address because this interface is in VLAN 1 by default, and this IP address is running on VLAN 100 interface. But we can put that interface in VLAN 100, 192.168.100.13. So run interface E1/2, no switch port, IP address DHCP. That is fine. Here what happened? Let me delete it and let me add the a new one. Stop this switch, and okay, Just a minute. IP address on this 241.138. It is fine, correct. Network adapter is NAT. Fine, fine, fine. Let me use one another device here. Let's say one I'm going to use one router here. R1, not R1. Turn on this router. Just wait for some time, or let me pause the video for a moment. Router is booting. Say no here. Enable config T interface F0/0. Let me verify the interface. Yes, F0/0. Say no shut and IP address DHCP. So IP interface brief. Debug DHCP details. This machine is not able to get IP from the DHCP. Yes, not able to get IP. What is the issue here? So IP interface brief. Just a minute. Let me pause the video and debug DHCP detail. Config T interface F0/0. Say shutdown and then no shutdown. Why this machine is not able to get IP? Turn off the devices and let me turn it on again. Here interface should be management, cloud management 0. And what we can do, yeah, now you can see this router is trying to connect with TFTP. After the boot up, this router is trying to connect with TFTP. Let me now delete this router because I'm not going to use it. Stop, delete this one as well, and I'm going to add one new cloud here, new virtual switch, and this time let me try to connect on the virtual switch, means cloud interface over here with router. You can connect with switch as well. Here select the management cloud and add it. Okay, let me connect to switch only, because maybe it will make you confuse. Now let me connect the switch again. Okay, and let me turn on the switch. Open it. Enable Cisco @123 and show IP interface brief. This interface is unassigned. Go to interface E1/2, say no such and no switch port and IP address DHCP. Okay, if this machine, this interface is not getting IP address from DHCP, we can configure one IP address statically from the same subnet, right? From the same subnet I can configure one static IP address, but you can see this time this switch have got the IP address. IP address is 192.168.241.157 and subnet mask is 255.255.255.0, right? And you know the IP address of TFTP server. IP address of TFTP server means IP address of your local machine. So let me open the CMD and say IP config. So IP address of your local machine on the virtual interface is 192.168.241.1. So now let me ping this IP address from the switch. Ping 192.168.241.1. Ping should work, or maybe my firewall is dropping the ICMP packet, because guys on my local computer firewall is enabled and that firewall is blocking the traffic, right? This is the reason why I'm not able to ping the local interface from the PC. Now I am going to ping this switch. So let me open CMD and from the PC let me try to ping this switch. Switch IP address is so IP interface brief exclude unassigned. So this machine have got this IP address 192.168.241.157. So say ping and this IP. You can see ping is working. That means from my local PC I am able to ping switch. Correct? Can I ping to router? Can I ping to router? Let me try. Let me try to ping router. So router IP address is 192.168.0.6 is the IP address of router, but it will not work. The reason, default router is not available maybe on your PC and route is not available on the router. Your core router don't have route for this IP 192.168.241.157. You can check the default route on your PC and then you can configure the route on your router, then you can ping router as well. Or simply what I can do, I can advertise this network in OSPF. In my internal network I am running OSPF routing protocol, so I can advertise this network 192.168.241.0 in OSPF, so that all router will get this network information. And now on switch 1, see here you have some data as well on the TFTP. Now if I want to back up the configuration of this switch, simply I can say copy running configuration to TF running configuration to copy running config to TFTP. Enter. Now it's asking you the IP address of TFTP server, means TFTP server is present on your local machine. So IP address of TFTP server is 192.168. Even you can use any IP address, but make sure that IP address is reachable from here, right? But as this on this interface IP address is 192.168.241.1 241.13, right? So I can ping dot 1 from switch number 1. If you want to access TFTP with another IP address, simply you can configure one default route, or you can configure the route, right? So here say TFTP and the IP address is 241.1. Now it is asking whether the file name. What will be the file name on TFTP server? Default name will be switch4 config. Okay, that is fine. Let me hit enter. And now you can see 1857 byte copied in 0.21 second. So now I have backup of the configuration of switch 4 on TFTP server. In the same way, I want backup of switch 3, but can I backup of switch 3 guys here? See, TFTP, sorry, password is Cisco @123. Now say copy running configuration to TFTP, then IP address of TFTP 192.168.241.1. File name is same. What it's saying? See, I'm not able to copy configuration of switch 3 on TFTP server. Reason being, switch 3 is not reachable from TFTP server. Switch 3 is not reachable from TFTP server. So on switch number 4, I'm running one protocol. So IP protocol. See, OSPF protocol is running. Routing protocol, I think OSPF is running on distribution layer switches, not on access layer switches. So that's why I told you to connect this virtual switch on distribution layer switch 1, right? Because guys, the IP address of TFTP server should be reachable from everywhere, right? Then only we can take backup. So, or the other option is what we can do, we can uh, configure any routing protocol, and then we can advertise that routing protocol over here. Or the other option is, see, on router switch number 3, I am going to configure one route for TFTP. See the error, right? So IP interface brief. On this switch, we have one IP address on VLAN 100 interface, right? And the gateway IP address is so run section gateway. Default gateway IP address ping. Let me access distribution layer switch 1 here. On distribution layer switch 1 for VLAN 100, so IP, sorry, Cisco @123. For VLAN 100, so IP interface brief. For VLAN 100, what is the IP address? This one, right? And so standby. Let me check the virtual IP address for VLAN 100, right? For the management VLAN. So standby, and we can say VLAN 100. So virtual IP address is 192.168.100.100. So from PC number 3, from access layer switch 3, I can ping this IP address to my gateway 192.168.100.100. See, I'm able to ping. The gateway is reachable, so I can configure one route here. Simply I can say IP route and 192.168.241.0 or 1 subnet mask 255.255.255.1. Exit interface is VLAN 100, right? So I have configured one route, right? And exit interface is VLAN 100. Do so IP route. So you can see the static route on the VLAN 100 interface, but still I cannot ping TFTP server. Ping 192.168.241.1. Ping is not working. Reason, distribution layer switch 1 don't have route. So on distribution layer switch 1 also I am going to configure one route. So see, the route is available on switch number 4, right? Route is available on from the TFTP is reachable from switch number 4. So I have to configure route on distribution layer switch 1 towards switch 4. towards switch 4. So a spanning tree for VLAN 100. You can see this switch, distribution layer switch 1 is connected with switch 4 on 0/3. 0/3 is the DP port, right? So I can configure one default route here towards switch number 4. Is it possible? It is possible, but you have to form IP connectivity between distribution layer switch 1 and access layer switch 4. So yes, there is IP connectivity. Switch 4 IP address is on VLAN 100 interface. So IP interface brief is 157. Sorry. Okay, 157 is the IP address of TFTP server, guys. I have configured wrong IP address here. On switch number, sorry, this is the IP address of switch 4. Correct. One is the IP address of TFTP server. Oh. Done. Now what we can do here, IP address on VLAN 100 interface is 192.168.100.13. so I can ping this IP address from distribution layer switch 1, ping 192.168.100.13. ping will work. I am able to ping. So can I configure route? IP route and 192.168.241.1 255.255.255.255, and I'm going to say next hop IP 192.168.100.13. right? Now can I ping to TFTP server? Ping 192.168.241.1. ping will work. I cannot ping because as my firewall is blocking the traffic, but my PC can ping to distribution layer switch 1 now. What is the IP address of distribution layer switch 1? So IP interface brief. So IP address of distribution layer switch 1 is this one, 192.168.10.254, last IP address from the subnet. Let me open the CMD, and now I'm going to ping 192.168.100.254. This ping should work. If ping is not working, then definitely there is some issue with firewall, right? Maybe firewall is dropping the traffic, but here from distribution layer switch 1, so IP route, there is one static route for the TFTP server IP address. Yes, and this IP address is reachable with this IP address. So IP ARP, for 100.13. So for 100.13, this machine have the MAC address, so it can encapsulate the packet. Then it will forward to switch 4. Switch 4 will forward it from their F1/0, from F1/0, because so IP route, you can see, because this network is present on 1/2 interface, so it will forward traffic from F1/2. Then why ping is not working? Ping 192.168. I'm able to ping switch 4 from here. Switch 4 IP address is this one. Yes, I'm able to ping VLAN 100 interface from here on switch 4. It is 100.13. No, this is the reason, guys, why I'm not able to ping. So actually these are the concept of routing. If you know the routing, you can make the reachability from the TFTP server to your all devices, right? And if TFTP server is reachable, then we can take the backup, right? So what we can do for now, I can configure switch 4 also as a TFTP server. Switch 4, let me try to do one thing on access layer switch 3. I'm saying copy running configuration to TFTP, and IP address of switch 3 192.168.100.13. Destination name is correct. So actually TFTP service is not enabled there on this switch, and even you cannot configure it. Let me check switch 4. So TFTP, so run include TFTP, no, so processes and include TFTP. So no, there is nothing for TFTP. So now here we have some issue with the routing, like maybe my firewall is blocking the traffic. What we can do, we can block the firewall, but I cannot block the firewall right now because my laptop is connected with internet. So this is the way to take backup of the configuration, but here I am not able to take backup of REST routers. But guys, concept is exactly same. In the real-time network, what you will do, you are going to add one separate server here in your network, and that server will be reachable. Like we can place that server in VLAN 100, and VLAN 100 is reachable from all devices, correct? Because this is management VLAN. Or let me do one thing, let me try to configure a routing protocol here on switch number 3, or sorry, on switch number 4. Okay, AGRP is enabled on both interface. Now let me take you to distribution layer switch 1. Actually, to identify the issue, what we can do, we can check the packet flow. See, when here IP address is 192.168.100.100 on the VLAN 100 interface. VLAN 100 interface. So if I am pinging TFTP server from the distribution layer switch 1, means I 192.168.241.1. So route is available on distribution layer switch 1 towards access layer switch 4. So it will forward traffic to this. This switch is going to forward traffic to the switch will forward traffic to my local computer. Now when my local computer will receive the traffic, it will hand over traffic to TFTP after checking the when I'm pinging, then my PC will hand over the traffic. It will generate ICMP reply message, and if traffic is belongs to TFTP, then definitely my local PC will hand over traffic to TFTP application. But in this scenario, now my PC is going to generate reply. So in the reply message, source IP will be this one, 192.168.241.1, and the destination IP will be 192.168.100.100. but on the local machine route is not available for this network. This is the reason why I am not able to ping, right? When I am pinging to this IP address from the local machine, local PC guys, from my laptop, so actually route is not available in that scenario. This is the reason why I am not able to ping distribution layer switch 1. So to add a route in the window operating, so let me try to add one route in the local PC routing table. So let me again open CMD, and here if you want to see the route, here simply you can run command show or not show route print. I think this is the command. Yeah, you can see all available routes here. We have one default route 0.0.0, and next up is the gateway IP address, right? The gateway is 192.168.1.1, which is the IP address of my internet router, right? So default route is pointing toward internet, right? So if default route will point towards switch number 4, access layer switch 4, actually just assume that this is nothing but this cloud is nothing but your PC have what IP 192.168.241.1, right? And this PC is connected with internet, and there is one default route 0.0.0.0 towards internet. Now on this PC I need to add one route. Which route? 192.168.100.100, right? Which is running in my network. So let me do one thing. Let me add that route, and then we'll try to ping distribution layer switch 1 from the PC. So here what we can do, say clear, and now I am going to add command route and command is add, I think add, can I use question mark here, percentage, and the network 192.168.100.0 mask is 255.255.255.0 and the next hop IP address. So I am going to configure this route toward access layer switch, right? Towards access layer switch 4. So IP address of access layer switch 4 is enable, so sorry, enable password is Cisco @123, and then say so IP interface brief. Here IP address is this one, right? So let me put this IP as a gateway. Now I have added this route in the routing table. If you want to verify, again you can run command route and print. Now let me check. This time we should have the new added network in the routing table 192.168.100.0. 192.1.0.1.0.50 is not there, you can see, and gateway is the IP address of access layer switch 1, which is reachable from here from the local PC. I am able to ping this IP address, right? Ping and 192.168.241. The IP address of this interface is, my gateway is 157.157.157. See, I am able to ping the access layer switch. Now let me try to ping the distribution layer switch 1 from my local PC, and this time I think ping should work. So the IP address of distribution layer switch 1 is ping 192.168.100.254, and yes, now you can see ping is working. So now my local PC is able to ping distribution layer switch 1, right? That means distribution layer switch 1 is connected with now TFTP. So let me take you to distribution layer switch 1 now, and from the distribution layer switch 1 I'm going to ping the TFTP server now. Ping, password is Cisco @123, and ping 192.168.241.1. See, from the PC, from the distribution layer switch 1, I am not able to send ICMP packet because firewall is dropping the traffic. But now I can send TFTP traffic, right? So let me try to copy running configuration to TFTP server. Running config to TFTP, and the IP address of TFTP server 192.168.241.1. Destination file name is same, and now you can see copy successful, right? 3558 bytes data copied in 0.1 second. Done. In the same way, you have to make reachability between all devices to the TFTP, right? So now, as distribution layer switch have route for the TFTP server, and I am running OSPF routing protocol. So what I can do, I can redistribute this network in the I can redistribute route in the OSPF. First of all, let me remove the EIGRP configuration, guys, because it will increase the CPU utilization here. Say no router EIGRP. Yes, number was do so IP protocol. So EIGRP is number 10. So let me say no router EIGRP is number 10, and on access layer switch 4 also I am going to remove EIGRP configuration. Config T, say no router EIGRP is number 10. And here on distribution layer switch 1 we need to configure one static route. So IP route. So is there any static route? Yeah, static route is there. Now let me ping again to distribution layer switch 1 from the PC, from the local PC, and see this time I am able to ping the distribution layer switch 1, right? So now I have copied the configuration of distribution layer switch 1 to TFTP server. Now I am going to redistribute this in OSPF so that other devices like core layer switch and firewall can also ping to TFTP. And if these devices are reachable with TFTP server, then I can take backup. So on distribution layer switch 1, I am going to say config T router OSPF process ID, router OSPF process ID 1, and then say redistribute static. I'm going to redistribute a static route, and after that you can configure the metric, or say subnet and then metric. So metric in OSPF is cost. Let me set 10 over here. Now these are not for you. Done. Now let me access the core layer router, and let me check the route. Enable password Cisco @123, and so IP route 192.168.192.168.241.1. Yes, now you can see route is available. So now I can ping this router as well from the local PC. Let me access, let me try to ping router from the local PC, ping, and the IP address is 192.168.0.6. Again, same issue. PC don't have route for this network, right? PC don't have route for this network, right? So again, I can add one static route here. Again, I can add one static route here. Say command is again route. What happened? Route. Then, and this is how we add route in the Windows operating system, right? You know well how to add route in the Cisco IS, and today you are learning how to add route in the Windows operating system routing table, right? Route is 192.168.0.4, and then mask is subnet mask is 255.255.255./30 means 252, and next hop IP address again access layer switch 4. So IP interface brief, this is the gateway. Let me enter. Done. Now let me try to ping again router 1, and this time ping should work. Just wait, ping will work. Let me check the routing table. Oh my god, video is getting lengthy. Route print is new added route available in the routing table 192.168.0.0 network not available. Let me hit this. Let me add this route here. What it's saying? Or I can do one thing. Simply I can say subnet mask 0.0 0.0 network ID 192.168.0.0. It will only match 16 bits value, but this route is actually overlapping somewhere. Route change this one. Actually I don't have much command on the window operating system. 192.168.0.0 is not there. 0.0 is not there. Okay, we will add this route. Just wait till then. Let me take backup of all access layer switches. Now see, from access layer switch 3 is TFTP server reachable. So IP Cisco @123. So IP interface brief, and this is the IP address of access layer switch 3. Let me check. PC is able to ping this IP address. Ping. Yes, PC is able to ping this IP address. That means TFTP server is reachable. Why switch is not able to ping, guys? TFTP because of firewall, right? So let me say copy running configuration to TFTP, and the IP address of TFTP 192.168.241.1. File name is same, right? Done. You can see. Then access layer switch 2, access layer switch to Cisco @123. Say copy running configuration to TFTP, and the IP address of TFTP 192.168.241.1. File name is same. What happened here? Again, access layer switch 2 is not reachable. Access layer switch 2 is not reachable. So IP route. So IP route. Here we have the static route, but on the access layer switch 2 we don't have a static route. So here also I need to add one static route. Just wait. Config T and IP route 192.168.241.1, and next hop IP address. Even I can configure the virtual IP address as well, guys. The HSRP IP address, which is 100.100, right? And 100.100 is reachable. Do ping 192.168.100.100. This is the gateway IP address. Yes, you can see ping is working. Now again go to the local PC CMD and ping. Now you can see I'm able to ping access layer switch 2. Now copy running configuration to TFTP. The IP address 192.168.241.1, and destination file name is same. Yes, you can see configuration is copied successfully. Now access layer switch 1. On access layer switch 1 also, first of all we need to add a route. Config T and IP route 192.168.241.1, 255.255.255, and gateway is 192.168.100.100. next hop IP. Right now you can ping switch 1 as well from the local PC. So IP interface brief, the IP address is .10 here. If you are not familiar with the IP addresses, that means you are not watching videos in sequence, right? If you will watch all videos in sequence, you will get everything. Right now you can see I'm able to ping access layer switch 1. So let's say copy running configuration to TFTP, the IP address 192.168.241.1. Done. Done. Now distribution layer switch 2. Distribution layer switch 2. Enable password Cisco @123 and show IP route 192.168.241.1. So you can see route is available in the routing table. That means I can copy the configuration, copy running configuration into TFTP, the IP address of TFTP server 192.168.241.1. File name is same. Yes, you can see, right? So now I have backup of all access layer switches, all distribution layer switches, right? In the same way, you need to take backup of this router and this ASA firewall, right? So what you need to do, guys, you only need to add this route and this network, these two network in the routing table of local PC. Means the condition is only there should be reachability, right? All devices should be able to ping TFTP server or your local PC. If all devices are able to ping the local PC, then simply you can install one software, TFTP software, and there are many type of TFTP software, guys, available on the internet. You can install anyone, and then you can back up your configuration, right? Now my configuration is saved on the PC, right? Now I can upload that configuration on drive or in the shared servers, right, which are accessible from everywhere, right? So this is the concept of TFTP and how to take backup of TFTP. Now I am going to stop the TFTP. I have stopped the TFTP, right? Now you can find your configuration in C drive. You can find your configuration in C drive, then matter where you want to save that configuration. Now you have backup of each devices. Now guys, video length is getting lengthy, so that's why I am not going to troubleshoot this issue, like why PC is not able to ping router and firewall, but the process is going to be same. Maybe I can make another video on it, right? Or I will ignore it because it is simple and now the concept is of routing, right? Now you know how to take backup in the real time. In the real time, you are going to backup of the configuration of each and every devices on a separate server, and that server should be accessible from all network engineers. So now let's suppose I want to replace one access layer switch or distribution layer switch, right? I don't need to again configure DHCP, right? HSRP, OSPF, whatever configurations are there, because I have already backup, right? And file name is different for all devices. So I can differentiate the configuration, file configuration, right? So that's all for today, guys. Now if you have learned something from this video, please hit on like button. If you have any question, concern, please let me know in the chat section, in the comment section. And this type of if these type of videos are helpful for you, if you want more videos like this, please type yes in the comment section. Your yes is going to motivate me to make more videos, right? If you have any other topics like scenario questions or any interview questions and you want video on that topic, please put that topic in the comment section. I will try to make video as soon as possible. And the last thing is, if you are new on the channel or if you are already watching my videos but you have not subscribed this channel, then guys, please subscribe this channel. Please support this channel because this channel is working very hard, right? I'm putting my 100% effort to create the content, right? I'm making videos in the easy language so that anyone can understand, but your support is required, right? Your support is needed. So if you want that this channel should grow and this channel should upload more videos in futures, please subscribe this channel, please like the video and type yes in the comment section. That's all for today. Bye bye. Thanks for watching.